Hello and welcome students. In today's lecture of planes, we are going for another theory, another concept, and that is the normal form of equation of plane. The normal form of equation of plane. So we had been writing the equation of planes in different forms. With the help of different given data, we found the equation of plane. Like if you remember, you found the equation of plane when you had one point on the plane and a vector perpendicular to the plane. Then you found the equation of a plane. When you had one point on the plane and two vectors which are parallel to the plane. Two vectors parallel to the plane. So what you did here, you took the cross product of these two vectors. You found the cross product. So you got this vector, and this vector happens to be perpendicular. So once again, same thing. You have a point and you have a perpendicular vector to the plane. Then finally we did equation of a plane when we have 3 points on the plane. We have 3 points on the plane. Okay, so with the help of these 3 points, we found two vectors. With the help of these 3 points, what we did was we found these two vectors. And then we found the cross product of these two vectors. So we got the normal vector, got that, and 1 point. Out of these 3 points, we took 1 point. So once again, so these are different ways we have solved we have found the equation of a plane. Now we are going to learn another very interesting form of equation of plane, and that is the normal form. Okay, I want you all to see this and say this again and again. It is which form? It is normal form. The normal form of equation of a plane. The normal form of equation of plane. Okay, now in this what happens is the equation of the plane at distance p unit from the origin. Okay, so you will have origin somewhere. Okay, you will have origin somewhere, right? So think this is z axis, this is y axis, and here we have x axis. We have x axis here. So if this is the case, then what will happen? You will have origin at this point. This is your y axis, x axis, z axis. Okay. Now I have a plane here. Okay. So there is a plane in space. So think this is the plane in space. What is said? It says the plane at distance p unit from the origin. So from origin, the distance is p units. What is the distance from the origin? It is p units. So there is a perpendicular from point O to the plane, and this perpendicular gives you the distance of plane from the origin. What does it give you? It gives you the distance. This is the perpendicular. This is the perpendicular from point O to the plane. So let this point be N. let this point be n here. What is n? N is the foot of the perpendicular. Okay. And this foot of the perpendicular is from the origin. You see this? It is from the origin. And how much is ON given to be? It is given ON equals to P units. P is a number, students. P is a number. ON is given to be P units. So from here to here. Okay, this is given to be P units. This is P units. See, the next part they say is, and to which unit vector n cap is normal. There is a unit vector n cap which is normal to the plane. There is a unit vector n cap which is normal to the plane. Okay, so that n cap is a unit vector, and that unit vector is perpendicular to this plane. So what direction that unit vector will be in? See, the direction of unit vector will be perpendicular to the plane. The direction of the unit vector will be perpendicular to the plane. So we can say that it will have the same direction as, it will be parallel to ON. You see this? Why parallel to ON? Because ON is also perpendicular to the plane. You got that? ON is also perpendicular to the plane. So here I have a unit vector which is perpendicular to the plane. Unit vector which is perpendicular to the plane. And this unit vector which is perpendicular to the plane, I call this as n cap. I call this as n cap. It is perpendicular to the plane, and I will call this unit vector as n cap. So students, see, what are the things that I am given? I am given a plane whose perpendicular distance from the origin is equal to P. P is a number. So what I am given is, if I draw a perpendicular from the origin to the plane, I will get, if I draw a perpendicular from the origin to the plane, I will get distance equals to P. I have distance of the plane from the origin as P, and I have one unit vector which is perpendicular to the plane. So this is my data. And with the help of this data, I have to find equation of the plane. Now listen, students, the first question that comes to my mind is this data what I'm given? Are this data enough for us to get the equation of plane? From the given data, will I be able to get the equation of plane? That is the first question that strikes my mind. And the answer is yes. So if you are thinking that how do you say yes? Listen, students, what are the minimum required things for getting equation of a plane? What are the minimum required things for getting equation of a plane? The minimum required things for getting equation of a plane are one point on the plane, that is either I should have the coordinates of one point on the plane, either I should have coordinates of one point on the plane, what does that mean? It means either I should have coordinates of a point on the plane, or I should have position vector. See, both are one and the same thing. If you have coordinates, you can find position vector. If you have position vector, you can find the coordinates of the point. or you should have position vector of a point on the plane. Got it? So you should have one point on the plane, and you should have one vector perpendicular to the plane. Now see students, what is happening here? The second part, which is one vector perpendicular to the plane, you can check here, you already have. See, you have a vector perpendicular to the plane. This unit vector they give you, this unit vector is a data. It is given to us. Okay, so the second part is there with us. Now the first part, which is one point on the plane, you might be thinking that we do not have the coordinates of a point on the plane, but you need not worry. Why? Because see, I have unit vector perpendicular to the plane. Now this unit vector has magnitude equal to 1 unit. Now this unit vector, if I multiply p to this unit vector, try understanding, to this unit vector, if I multiply p, what will happen? I will get p times n cap. Try understanding. What is p times n cap? Think. What is p times n cap? P times n cap will be a vector which is this vector. It will be a vector which is this vector. And see, we will get p n cap. P n cap is this vector. And the moment you get this vector, what you got? You got the position vector of point n. If you got Pn cap is On bar. And the moment you get On bar, you got the position vector of this point. You got the position vector of point n. So you have one point on the plane. And in this case, since you have one point on the plane and you have one vector perpendicular to the plane, you can write the equation of this plane. What you will do, you will take a variable point r which has position vector r bar, then you will have n bar. N bar is perpendicular to n cap. So you will write n bar dot n cap is 0, and then it can be done. I hope it's clear to you. Now I shall do the theory for you. I shall do the theory part for you. Wait. I write here n cap is a unit vector. N cap is a unit vector perpendicular to the plane. I will write here vector On bar and n cap. See, this is n cap here, right? This is n cap, this vector. So I will write vector On bar and n cap are parallel to each other. Parallel to each other. Now see, this On bar is nothing but n bar, small n bar. You see this? On bar is position vector of point n. So that is, you got it? So On bar, that is n bar is parallel to n cap. It is parallel to n cap. On bar is, you got that? Yeah. Now, position vector of On bar is n bar. So n bar is parallel to n cap. And what I notice, so if two vectors are parallel to each other, one vector is a scalar multiple of other vector. What is it? N bar is P n cap. Guys, look at this. See students. N bar, this is n bar from here to here. What is n bar? N bar is P times of n cap. So now next step, I will take a variable point on the plane. I will write here let r bar be a variable point on the plane. Let r bar be a variable point on the plane, on the plane. Therefore, see what will happen next. Therefore, nr bar, you check this, nr bar is perpendicular to n cap. Nr bar is perpendicular to n cap. Therefore, nr bar perpendicular to n cap. Definitely yes. Why? Because nr bar is in the plane and n cap is perpendicular to the plane. So nr bar is perpendicular to the plane. So what you will write next? Therefore, you will write nr bar dot n cap. Nr bar dot n cap is equal to 0. When two vectors are perpendicular to each other, their dot product is 0. Therefore, you will have r bar minus n bar dot n cap equals to 0. And what is n bar? N bar is p times n cap. You see this? N bar is p times n cap. So I will use it here. I write this as 1. So using 1, we get what you will get. See, the next you get is, this will become r bar minus p n cap dot n cap equals to 0. Therefore, you will have r bar dot n cap minus p n cap dot n cap equals to 0. Now you know, if you have a bar dot a bar, you write it as mod a bar square. Got that? So here you have n cap dot n cap. So this will become r bar dot n cap minus p into mod n cap square equals to 0. Therefore, you will have r bar dot n cap minus p bar. I'm sorry, not p bar, minus p. P is a number. It's a number. It is distance of plane from the origin. And what is mod n cap, students? It is 1. N cap is a unit vector. So its magnitude is 1. So here you have 1 square equals to 0. Now 1 square is 1. P into 1 is p. So you will have therefore r bar dot n cap equals to p. And guys, look at this. What is this? It is equation of the plane in normal form. Students, this is equation of the plane in normal form. This is the normal form of equation of plane. You can watch this once again. This is the end that we have here. Now here we have some important points that we need to remember for the normal form of equation of plane. Okay, so just now we did the normal form of equation of the plane. What we did the normal form of equation of plane. With regard to that, there are certain important points that you need to remember. Okay, look at this, students. R bar dot n cap equals to p. This is distance of the plane from the origin, whose equation you wrote. This is distance of the plane from the origin. This is the position vector of a variable point on the plane. This is position vector of a variable point on the plane, that is xi cap plus yj cap plus zk cap. You know this? Yes. R bar is always going to be xi cap plus yj cap plus zk cap. What is this? What is this? It is the unit vector perpendicular to the plane. It is a vector perpendicular to the plane. So as I wrote, see the variable point which is r, how would I write the position vector? I will write it as r bar. And that r bar, if I want to write in terms of basic unit vectors, I cap, j cap, k cap, I would be writing r bar like this. See, I wrote r bar like this. Why? Because because point R, the coordinates are x comma y comma z. The coordinates are x comma y comma z. So R bar is xi cap plus yj cap plus zk cap. Got it. Here the question is, as I wrote R bar as xi cap plus yj cap plus zk cap, how would I be writing the n cap? How would I be writing the n cap? See, for writing n cap, which is the unit vector, you should have the direction cosine of the normal to the plane. What you should have? You should have the direction cosine of the normal to the plane. Okay. So now here we come to that point. See, I write here, if the first point is, if L comma M comma N are direction cosines of of normal to the plane, then then n cap will be equal to Li cap plus Mj cap plus Nk cap. Then this is the way you will write the position vector of, this is the way you will write the unit vector. Students, if you remember, when I had introduced to you the concept of DCS, direction cosine of a vector, when I had introduced the concept of direction cosines of a vector, I had told you clearly, when I know DCS of a vector, I can write unit vector in the direction of that vector. I repeat again, when we know DCS of a vector, we can write unit vector in the direction of that vector. Now, when I know the direction cosine, when I know the DCS of normal, I can write unit vector in the direction of normal. And what is the unit vector in the direction of normal, my dear students? The unit vector in the direction of normal is n cap. Okay. So suppose if you have a normal vector to the plane this way, if you have a normal vector to the plane this way, see, this is normal vector. I know the DCS of this vector. So if I know the DCS of this vector, which are L, M, N, I can write n cap as Li cap plus Mj cap plus Nk cap. Okay. So this is one point that you need to be knowing. Now, point number two. See, for point number two is what I will do. I will put what is that n cap I got? I got n cap as this. So I will write this. I write it as this. I write as equation number two. So I write using n cap. Using n cap in two, we get what you will get. You will get r bar. Okay, what is R bar? R bar is xi cap plus yj cap plus zk cap dot. What is n cap? N cap is li cap plus mj cap plus nk cap equals to p. So what will this become, students? This will become therefore. Lx plus My plus Nz plus Nz equals to P. Lx plus My plus Nz equals to P. And what is this? This is the normal form of the equation of a plane. This is the normal form of the Cartesian equation of plane. See, this is normal form of the vector equation of a plane. This is, what was this? This is the normal form, but it was vector equation. This is normal form, but Cartesian equation. So here I will write this equation. This equation is the normal form of the Cartesian equation, normal form of the Cartesian equation of the plane. Listen, students, if I write some equation, this is very, very, very important. I want you all to be very attentive. See, if I write some equation, 2x plus 3y minus 4z equals to 17. Okay. So any such equation which is in the form some coefficient x plus some coefficient y, then some coefficient z equals to some number, that is ax plus by plus cz equals to d. If you have any such equation, remember students, it is a plane. It is a plane. This is what? It is a plane. Like you remember when you were in 11th standard and you studied straight lines. So there we said ax plus by plus c equals to 0. This is the general equation of a straight line. Ax plus by plus c equals to 0. This is general equation of a straight line. When you have any equation in this form, you write this as a line, a straight line in xy plane. What do you say? This is a straight line in xy plane. It is a straight line in xy plane. So when you have any such equation, you call it as a straight line in xy plane. On the same line, you can say, when I have any such equation, what equation? Ax, when I have some equation which is in the form ax plus by plus cz equals to d. Now see, here you have got z component as well. For the line, what we had ax plus by plus c equals to 0. Here what we have ax plus by plus cz equals to d. Or plus cz, for that matter, plus cz plus d equals to 0, whatever it is. Okay, because writing a constant here, you can always take a constant on the left. What is this? This becomes a plane. This is a plane. This is always a plane. Remember. And when you say this as a plane, see this. Ax plus by plus cz plus d equals to 0 is a plane. Okay. Now in this equation, what are a, b and c? What are they? They are, remember, they are DRS of normal vector. They are DRS of normal vector. You must follow this. They are not DCS. They are DRS. A, B, and C are DRS. When I write, now look at this. when I write Lx plus My plus Nz equals to P. So if you write here, then it will become minus P. Like you have D here, that is P. Okay. Now here, what are L, M, N? Try understanding. A, coefficient of X, it is. B, it is coefficient of Y. C is coefficient of Z. So what are A, B, C? They are the DRS of normal vector. And what are LMN? What are LMN? They are the DCS of normal vector. They are DCS, my dear students. They are DCS of normal vector. And because they are DCS of normal vector, remember this number is perpendicular distance from the origin. This number is the distance of the plane from the origin. This number is distance of the plane from the origin. This number is not the distance. Please, this number is not the distance. Why? Because the coefficients of x, y, z are not DCS, they are DRS. This one has to follow. Very, very, very important concept it is. Okay, what did I say? I say that once again. This side, I have ax plus by plus cz plus d equals to 0. When I notice the coefficients of x, y, and z, they are not DCS, they are DRS, then the constant thing which I have, this constant number which I have, it will not be the perpendicular distance of the plane from the origin. Whereas when I notice that in the equation of a plane, the coefficients of x, y, z are direction cosines of the normal vector, then I will say that the constant number which I have, it is the distance of the plane from the origin. Now, if you are having a question that how would I know that it is, how would I know that the given coefficients are DRS or DCS? See, very simple, students. When you will square all the coefficients and you will add them, if it is equal to 1, then they are DCS. If it is equal to 1, then they are DCS. And if it is not equal to 1, they are DRS. Very simple, because you know L square plus M square plus N square is equal to 1. Now we have here the third pointer. The third pointer that we will have here is the coordinates Okay, so now we are going to solve problem based on normal form, which we just learned. See, the first question from exercise 6.3, here you have. Find the vector equation of a plane which is at 42 unit distance from the origin and which is normal to the vector 2i cap plus j cap minus 2k cap. Okay, before I begin, I want you to answer few things. What are the data here? The data is I'm given distance of the plane from the origin. See, find the vector equation of a plane, which is at 42 unit distance, 42 unit distance from the origin. You got that? So this is first data we are given. We are given the distance of the plane from the origin and which is normal to the vector 2i cap plus j cap minus 2k cap. Okay. But you know, students, this vector which is normal to our plane, see, think this is our plane. We are given the distance of this plane from the origin. We are given the distance of this plane from the origin, that is 42. This is say O, this point is say N. We are given the normal vector. We are given the normal vector, that is, we are given N bar. But you know, in order to write the equation in normal form, in order to write the equation in normal form, what we need? We need the unit vector perpendicular to the plane. We need N cap. We don't need N bar. I hope you understand this. We need N cap. When we have N cap, then only we can write the equation of the plane in normal form. You would be thinking that why you want normal form? Why not write the equation of the plane in some other form? See, students, I want normal form because they have given me this distance of the plane from the origin. They are not giving me one point on the origin. I'm sorry, one point on the plane. If they give me the coordinates of the plane, if they give me the coordinates of one point on the plane, then I can do this in the other method. I can do this by the other method. What is it? One point on the plane is given. The normal vector to the plane is given. Take a variable point r, then say nr bar is perpendicular to n bar, and then go for different method. Here what's happening? They are not giving the coordinate, they are not giving the coordinates of a point on the plane. Instead, what they are giving us? They are giving us the distance of the plane from the origin. Okay, I hope you followed it. So the first thing I will do is what? I shall find out the unit vector in the direction of the normal. Okay, so here I will begin with my solution. I will write here, see the answer. The normal vector, the normal vector is 2i cap plus j cap minus 2k cap. Okay, I write this as n bar. This is normal vector. I will write let n bar equals to 2i cap plus j cap minus 2k cap. Then I will write let n cap be a unit vector in the direction of, in the unit vector in the direction of n bar. Okay, that is, n bar is normal vector which is perpendicular to the plane. And what is n cap? N cap is also in the direction of n bar. So n cap is also perpendicular to the plane. But the only thing is n cap is a unit vector. Got that? So n cap is like this. I want a unit vector perpendicular to the plane. And what have they given? They have given me a vector perpendicular to the plane. They have given me like this. What I'm doing? I'm finding n cap. Okay. So the next step I write, therefore n cap is equal to n bar upon mod n bar. Okay. What is mod n bar? That is 2i cap plus j cap minus 2k cap upon mod of n bar square root of 2 square 4 plus 1 square 1 plus minus 2 square 4. So that is 2i cap plus j cap minus 2k cap divided by root of square root of 9, which is 3. Okay. Okay, 4 plus 4, 8, 8 plus 1, 9. Square root of 9 is 3. So next step I have, therefore n cap is equal to 2 upon 3 I cap plus 1 upon 3 j cap minus 2 upon 3 k cap. See students, I got the unit normal. This can be called as unit normal. That is, it is unit vector perpendicular to the plane. Now what I will do? I will go for the equation of the plane. So now see here, I write here, let r r bar, let r bar be a variable point on the plane. Okay, therefore now you know what you know. Therefore equation of the plane can be given as, you know, r bar dot n cap equals to p. So r bar dot n cap equals to p, where p is 42. What is p? P is 42. P is the perpendicular distance. So you have therefore r bar dot n cap 2 by 3 I cap plus 1 by 3 j cap minus 2 by 3 k cap equals to 42. Okay, if you want you can multiply throughout by 3. If you want you can multiply throughout by 3, or you can leave it this way also. So if I multiply throughout by 3, I will get therefore r bar dot 2 I cap plus j cap minus 2k cap, and here you multiply by 3, so this is 126. This is required vector equation of the plane I hope you followed it. Please copy this. Okay, so now we have another very interesting question. This is number 2 from the same exercise. Find the perpendicular distance of the origin from the plane. So the given plane is, I write the equation of the given plane. What is it? 6x minus 2y plus 3z minus 7 equals to 0. That is, now I write this 7, my negative 7 on the right side. So I'll get 6x minus 2y plus 3z equals to 7. So students, this is definitely a plane. I told you earlier that any equation which you have in the form ax plus by plus cz plus d equal to 0, okay, this is a plane. So see here, we have a plane here. This is nothing but a plane. But this equation of the plane is not the normal form. It is the Cartesian equation of the plane, but this Cartesian equation is not in normal form. Why this is not in normal form? How do I know it is not in normal form? And why do I need it? Why do I need it to be in the normal form in the first place? Why I need this to be in normal form? Listen, they want the perpendicular distance from the origin. I know if I have equation of a line in normal form, then the number on the right hand side is the perpendicular distance of the plane from the origin. I repeat again, when I have equation of a plane, in normal form, then the number which I have on the right hand side, that number is the perpendicular distance of the plane from the origin. Now see, normal form of the plane in vector equation is r bar dot n cap equals to p. And normal form of the Cartesian equation of plane is Lx. What it is? It is Lx plus My plus Nz equals to P. So here we are given the Cartesian equation. So what do I understand? It has to be Lx plus My plus Nz. That is, I should be having these three numbers as the direction cosines. And what they are direction ratios of the normal. These three numbers should be the direction cosines of the normal. They are the direction ratios. How do I know they are the direction ratios? Because if I take the square of these numbers, see, if I take the square of these numbers, 6 square plus minus 2 square plus 3 square, am I getting 1? No, I'm getting 36 plus 4 plus 9. This is not equal to 1. So I understand that 6, negative 2 and 3, they are not the DCS. They are not the direction cosines. What are they? They are the direction ratios of normal to the plane. They are the direction ratios of the normal to the plane. So first I will do is what? I will write this equation in the normal form. Okay? I will write this equation in the normal form. Okay. So I write here in the above equation, of plane 6, negative 2, 3 are the DRS of normal to the plane. What are they? They are DRS of normal to the plane. I want to get the DCS. So what I will do, see students, you already know it. If you want the DCS of normal, then from DRS, if you want DCS, the idea is, what do? You will divide throughout by, you will divide each number by 6 square plus minus 2 square plus 3 square. What you will do? You will divide each number by 6 square plus minus 2 square plus 3 square. That is, you will divide each number by 36 plus 4 plus 9. That is 40 plus 9 is 49. That is 7. Okay, so what I write? I write here. See, I want these numbers to be converted to DCS. Okay, which number? These numbers. These numbers are DRS and I want them to get converted into DCS. What is the idea? The idea is I divide each one of them by the square root of sum of squares of these numbers. Okay, if you remember, when I had taught you how to get DCS from DRS, suppose DRS are A, B, and C. Okay, so what was it? If these are DRS, then the DCS will be A upon square root of A square plus B square plus C square, comma, B upon square root of A square plus B square plus C square, comma, C upon square root of A square plus B square plus C square. I hope you now can recall that. So here what I will do, students, I will divide throughout the equation 1. I write here dividing throughout equation 1 by 7. Why 7? I just calculated. Square root of 6 square plus minus 4 square plus 3 square is 7. So I will get here 6 upon 7x minus 2 upon 7y plus 3 upon 7z equals to 7 upon 7, that is 1. Okay. And now I write. What I write? See, students, this is this equation which you have here. This equation which you have here is the normal form of Cartesian equation of plane. I will write the above equation, the above equation is the normal form, it is the normal form of Cartesian equation of plane, that is in the form, Lx plus my plus nz equals to p, where p is the distance of the plane from the origin, where p is perpendicular distance of plane from the origin, therefore the perpendicular distance of given plane from the origin, see what is it, 1, see the right hand side what number we are getting, 1, the given plane from origin is 1 unit, it is 1 unit. I hope you followed it. Please copy this. The equation of the plane is, I will begin with, the given plane is, see in this question, this is third question, what we have to do. They say find the coordinates of the foot of the perpendicular drawn from the origin to the plane. So they give us a plane, here, and to this plane from the origin a perpendicular is drawn. From the origin a perpendicular is drawn. Now that perpendicular will definitely meet the plane at some point. That point is the foot of the perpendicular from the origin. You have to find the coordinates of that point. Okay, so I will begin writing as the given plane is 2x plus 6y minus 3z equals to 63. Okay, I will convert this equation in normal form. This is the Cartesian equation. I will convert this into normal form. Okay, for converting it into normal form, students, what I will do, these numbers which are the coefficients of x, y and z, they are DRS. I will convert them into DCS. And for that, what is the idea? The idea is very simple. See, I will divide throughout the equation by 2 square plus 6 square plus minus 3 square. 2 square plus 6 square plus minus 3 square. That is square root of 4 plus 36 plus 9. That is 40 plus 9, 49. Root of 49 equals to 7. What I will do, I will divide throughout the equation by 7. I will write here. Dividing throughout the equation, by 7. So when I do this, see what I get. I get 2 upon 7x plus 6 upon 7y minus 3 upon 7z equals to 63 upon 7. Therefore, 2 upon 7x plus 6 upon 7y minus 3 upon 7z equals to 9. Okay. Now what I have, see this equation is Cartesian equation of the plane in normal form. This is normal form of Cartesian equation, of given plane. Okay, I will write. The next I will write, therefore. I will write here. Therefore, the perpendicular distance. Now see students, this right hand side number, once you have written the equation in normal form, the right hand side number is the perpendicular distance of the plane from the origin. I will write therefore the perpendicular distance of the plane from origin is 9. Okay, it is 9. This is, I'll write let p equals to 9. Okay, from equation 2 now I can write the DCS of the normal to the vector. What do you say? I can write the DCS of the normal to the vector. DCS of the normal to the plane. I'm sorry, I said normal to the vector. I can write the DCS of the normal to the plane. So here I will write from equation 2, the DCS of normal to the plane is given as 2 by 7, 6 by 7 minus 3 by 7. Okay. So therefore now we can write the coordinates of foot of perpendicular. See, therefore m equals to 2 by 7. I'm sorry, it is not m, it is L. LMN. Therefore L equals to 2 by 7. This is L. M equals to 6 by 7 and N equals to minus 3 by 7. So LMN we got. So see students, the foot of the perpendicular is given by PL, PM, PN. Therefore the foot of the perpendicular, therefore the foot of the perpendicular drawn from the origin to the plane is PL, PM, PN. That is PL. What is P? P is 9. 9 into 2 by 7. That is 18 upon 7, PM. That is 9 into 6 by 7. 54 by 7. 54 by 7, 9 into minus 3 by 7. That is minus 9 into PN minus 3 by 7. That is minus 27 by 7. Okay, this is the answer. I hope you followed it. Please copy this. So here we have the last question of this section based on this particular concept. That is question number 4. Reduce the equation r bar dot. See, they give us an equation. They say reduce the equation r bar dot this vector equals to 78. R bar dot 3i cap plus 4j cap plus 12k cap equals to 78 to normal form, and hence find. We have to convert this equation to normal form. Okay. And hence find the length of the perpendicular from the origin to the plane. We have to find the length of the perpendicular from the origin to the plane, and we have to find the direction cosines of the normal. So here we will begin with the answer. We will write the given equation. The given plane is, what is the given plane? It is r bar dot 3i cap plus 4j cap plus 12k cap equals to 78. Now see students, this equation is definitely not in the normal form. Why? The reason being, the normal form is r bar dot n cap equals to p. Now see r bar dot n cap. Remember, with r bar, with the position vector of the variable point, we should have n cap. What is n cap? N cap is the unit vector that we should have. And this is not unit vector. This is not unit vector. How do I know? This is definitely the normal vector, but it is not the unit normal. It is not a normal vector which is unit vector. It is definitely perpendicular to the plane, but it is not unit vector. So what I will do, first of all, I will change this into a unit vector. Okay. Now see, for that, what I will do is, we all know that whenever we have any such equation, then in such equation of plane, these numbers, that is the coefficient of I, J, and K, they are the DRS of the normal. I will change this DRS to DCS. And the moment I do this, then the vector which I will get, it will become a unit normal vector. Okay. So see students, what I will do. I will have to change 3, 4, and 12 to DCS. And for that, the method is known to you. See here. I will divide throughout by 3 square, square root of 3 square plus 4 square plus 12 square. That is square root of 9 plus 16 plus 144. So this is 144 plus 6, 150, 60, 169. That is square root of 169 is 13. Square root of 169 is 13. So what I have to do, I have to divide throughout by 13. Okay. I write here dividing throughout the equation by 13. I write dividing throughout equation 1 by 13. Therefore, see what you get. You get r bar dot 3i cap plus 4j cap plus 12k cap, the whole divide by 13. You know, in dot product, you can divide by 13 any one of these two. You could have divided the r bar, or you could have divided the vector. Okay. So divide by 13. I divided by 13, and then here also 78 divided by 13. So what will this give you? So r bar dot, now see, this is 3 by 13 I cap plus 4 upon 13 j cap plus 12 upon 13 k cap equals to 6. 13 6 are 78, right? Equals to 6. Now this equation 2 which you got, this equation is the normal form. You got it? So here I write here equation 2 is normal form of vector equation of plane. Normal form of vector equation of plane. Therefore, that is in the form r bar dot n cap equals to p. Okay. Therefore, p equals to 6. See here, the right hand side 6. Therefore, the perpendicular distance from the origin is 6 units. Therefore, see, we got the answer of the first part, the length of the perpendicular from the origin. Therefore, the length of perpendicular from origin equals to 6. Equals to how much? 6 units. 6 units. Then we have the next. The next is direction cosine of the normal. Now see students, once you have converted into normal form, these coefficients of I cap, j cap, k cap, they are the DCS of the normal. I will write 3 by 13, 4 by 13 and 12 by 13. So the next step, what I write? The DCS, the second, okay? The answer for second. This was the answer for first. I will write. The DCS of normal are, what are they? 3 by 13, 4 by 13, 12 by 13. This completes the solution for fourth question. We have had enough problems on this concept. Please watch this again and solve it.